OK, let's talk about how to stop SQL injection attacks. So one attack is kind of similar to its cousin attack, XSS. And the defense is to sanitize your inputs. If the user is being asked for a string, like the name of an item they want to buy, they probably shouldn't be entering special keywords like or 1 equals 1, or quote, or double dash. So one thing we can do is disallow special characters and tell the user, your input has to be a sequence of English characters, A through Z. And you can't type quotes or dashes. We're not going to allow those. Or if we're asking the user how old they are, the answer is probably not or 1 equals 1 quote. That's not an age. Maybe we say the user's input has to be a number. So that's one option, is to disallow special characters. Or you could escape the characters. So even if someone enters a quote, you escape it with a backslash. And now it's treated like a literal quote, as opposed to a special character in SQL. And once again, the drawback is that building a good escaper is tricky. There are ways to get around escapers. And so instead of building your own, a better idea is to use existing libraries that do this for you. So for example, this code seems to be calling some predefined SQL escape function on the user input. Now, an even better defense against SQL injection is something called a prepared statement. Now, we're not a SQL or a databases class, so I'll give you a rough picture of how this works. But if you take a databases class, maybe I've simplified it a little bit. So this query, when we run it on a database, the first thing we have to do at some point is to take this query, which is English characters, and compile it into some sort of database-friendly language, something like relational algebra or something. I'm not a databases expert. But you can imagine at some point, the SQL interpreter will take these English characters, A through Z, and compile them into something that databases actually understand. Now, the problem that we are having is that the attacker is inputting a special string with characters like or 2 dashes. And then the English string is being compiled into some database-friendly language. So that's our problem. We're compiling after the attacker has already substituted in their malicious input. Now, a different approach might be to switch the order around. So what if, instead of compiling this after the attacker has substituted in something malicious into the question mark, what if we first compiled this and we said, read this English string as code, compile it into something that the database already understands, and leave this placeholder. We don't know what it is yet. Just leave it as a placeholder in the compiled version of this query. And then only after you finish compiling this query and translating it from English into some database-friendly language, do you then take the attacker's input and substitute it into the query. So by the time the attacker's input is substituted into this query, it has already been parsed and compiled and translated into a different language. So even if the attacker types quotes or dashes or other special characters, it's too late. They're not going to be treated as special data. So you could compile this to some language and then substitute in a literal string after all of the parsing is already done. And at that time, the user string will not be parsed a second time. So it's going to stay there as a literal string, even if it has special characters. So that's called prepared statements. And it's an even more robust defense against SQL injection attacks. So what's good about prepared statements is that they basically stop all of the SQL injection attacks. So this is kind of like the equivalent of using a memory-safe language when we talked about C. This is one of those defenses where we can say, if you use it properly, you are stopping 100% of SQL injection attacks because the attacker's input will never be treated as code. So if we have a defense that works 100% of the time, why was this in the top 20 most common attacks? So one downside of prepared statements is that they're not always part of your SQL implementation. So if you do study databases, you'll know there's different implementations of SQL that run underneath the SQL language. Not all of them have prepared statements. Some of them have different ways you call prepared statements. For example, this one used a question mark, but maybe a different SQL interpretation wants you to put something else that's not a question mark. So you'd have to look up the exact syntax for how your SQL interpretation or implementation implements prepared statements. So once again, this is kind of a human factors thing. This defense does exist, and it's very effective, but humans have to remember to use them. They have to be aware that this is a problem they have to solve, and they have to know the correct syntax for their specific SQL engine to implement this defense. So maybe that's why SQL injection is still there in the top 10. It's because even though the defense exists, not everyone knows about it or remembers to use it all the time.